This is Dr. Sajja Suneel from Data Science Department. Today I am here to discuss a brief overview about IoT network and management systems. And this particular class is purely going to discuss about different kinds of networks and different kinds of management techniques which are existed in our Internet of Things. This was a brief overview for our module 2, which will be helpful for reviewing the things which we discussed so far in the past classes, guys. Have a look, guys, what exactly existed in module 2. In this IoT network and management, there are main two different things, IoT and M2M. IoT stands for Internet of Things, M2M stands for machine to machine. In this particular thing, we are having a few topics which we are going to have a brief overview about these things in detail in the coming slides. Have a look. The first one is SDN and the second one is NFV, and also the third one is the difference between these two. The difference between these two. That was the third one. And also we are knowing about the basics of IoT system. And also you guys are knowing about Netcom, Yang, and SNMP Netoppear. These are the things which I am going to discuss today in this particular module. Have a look, guys, what are the things which are existed, what was the objective and what was the outcome for this particular module. Here you guys need to ensure a reliable and scalable connectivity. You guys to enable security communication, and you guys need to provide efficient data management. You guys need to provide improving the performance and simplifying networks. And what are the outcomes, students? You are going to be able to know about how improved operational efficiency was, and also you guys are able to enhance the security, scalability and growth. You guys are able to reduce the downtime of customer experienced. What machine to machine was? Machine to machine is going to refer you the networks of machines or devices for purpose of remote monitoring, control and data exchange. The diagram is going to show you what are the different kinds of machine to machine area networks and how these are communicating by using a gateway with M2M, machine to machine core network, and by using a particular gateway, how wireless network is going to connect it with our applications. Everything is shown in this concerned diagram. Once have a look. And this is about the internal process, how the things are. Whenever an accident is happened, automatically the information is going to be sent to the nearest tower signal where the servers are existed. And from that particular servers, again, it uses the same mobile network and sends information to the local hospital and the local ambulance and the local doctors. Automatically, these guys are going to be alerted and automatically they are going to attend the person. And again, doctors will attend paramedic, and the paramedic team was also going with them in ambulance. This is how the things are going to pursue whenever in a real scenario. What M2M and what IoT was? I already told you M2M was a machine to machine and IoT is the Internet of Things. Here we are communicating with machine to machine. There we are communicating with sensor. Here there is a point-to-point communication. There it was a cloud-based connection. Here device doesn't require any kind of relay or internet. Here it requires relay and internet. Here this machine to machine is mostly on hardware. There it is mostly both hardware and software. And here machine will communicate with single machine at one time. There it can access anytime over the network with many users. And coming to machine, it was a non-IP based protocol, whereas IoT was a IP based protocol. And coming to think, it was a business to business type, whereas it was business to business as well as business to customer also. The business types are existed in IoT. And here in machine to machine, it was a limited number of devices which are connected, whereas in IoT, more number of devices can also be connected. And here we are not supporting any kind of APIs in machine to machine. Whereas in IoT we are supporting with open APIs. And here in machine to machine it was a less scalable compared to IoT. Why? Because it was more scalable due to its features, guys. And now we will move to the next part, which is machine to machine gateway. And in this machine to machine gateway, we are rerouting the things by using the virtual nodes such as NAV protocol translation, proxies, which are M2M gateway. Through this gateway, we are connecting with the node and we are connecting with the some other node also. And here the networks such as Bluetooth, Zigbee, 802, Wi-Fi, LISIC, WAN Wi-Fi, and MBus, wireless MBus, and UMB, Mobibus, JetWave. All these are the things which are existed in this particular gateway, guys. And how a communication will be happen in IoT and M2M. Once if you observe this particular diagram, you'll come to know what are the different kinds of things which are existed in between this IoT and M2M. Once if you observe the thing, here the application layer was almost same in both the things and the transport layer was same in both the things, but these two can be used only in IoT, whereas in machine to machine we are using with network layer and link layer. The same kind of design is being implemented. This is how a current network system is going to be stepped on, right? Have a look how the things are and how the data is going to be represented in form of the OSB protocol execution, as well as the switch is going to be attacked. Every information will be maintained in form of table. And have a look what are the different kinds of limitations. The limitations such as vendor specific architecture, switches limited architecture, and the limitations are 1000 lines of code, routing mobility, cost expenses, million of gate. All these are applications, and this is operating system. This is a packet delivery. All these are the things which are existed. And this was the current then, and this was the SDN architecture. In this SDN architecture, there was a particular operating system which is existed at network map abstraction point layer. Excuse me. We'll continue. Yeah. Here in this well-defined API, security, routing, traffic, other applications are there in network virtualization. And coming to the network operating system, we are having data plane which is forwarded, and from there it is going to be used the data. This is how SDN network is going to be. Here we are having application layer, control layer, infrastructure layer. Whereas the control layer and infrastructure layer, in between there was a network operating system which acts as an interface between the above northbound open API and the below southbound API. Here in between we are having network operating system. Here the above things are control layer, the below things are infrastructure layer. These things in infrastructure layer we are having simple packet forwarding hardware which is going to be existed. And coming to the application layer, we are having network applications and number of types, and in between there will be a network operating system. Whenever you want to communicate with the northbound, you need to connect with the operating system. Then only it is able to connect with the other end. What SDN was, I already told you, it was a networking architecture which is going to separate the control plane and data plane, which is going to centralize the network controller. The key elements such as centralized network controller, programmed API, standard communication interface, which is an open flow. These are the key elements, and open flow, which I discussed previously. And this was the diagrammatic representation. Key elements of SDN: centralized network cover, programmable API, standard communication interfaces. These are the key elements which are established in NDF. And this network function virtualizer. In this network function virtualizer, which is a technology which is going to leverize the virtualization concept to consolidate the heterogeneous network into industry, which is very complementary to both SDN as well as NFV, by providing the infrastructure where SDN can run it. Got it, guys? So that these two, NFV and SDN, are mutually beneficial to each other, but not they are dependent or independent. Got it, guys? And see, this was the network functional virtualization. If you observe this network function virtualization, there are multiple images which are drawn very clearly for your better understanding. And coming to NFV infrastructure, virtual compute, virtual network, virtual storage, which plays a major role in this NFV infrastructure. In between them, there will be a virtualization layer which is going to compute, network, storage. All these things are connected with this network F function virtualization or stagation. This was the block diagram for NFV, network function virtualization. And what are the key elements? Virtualized function network, virtualized network infrastructure, and how the connection in an home network environment is. If you observe the scenario, this was the public network which is placed in a circuit. And through this public network, there are different kinds of interfaces such as IPTV, Internet, VoIP. All these are the Internet service providers who are providing to your public network. Through this public network, you are transferring it to router, and from there we are having VoIP, iPhone, IPVT, and home gateway, smart refrigerator, smart washer, single board computer, lights, doors, everything was smart in home network architecture, guys. This is how we are moving. And coming to NFVs, which use case are such as conventional home automation and architecture. These are the things which are connected with our public network such as virtual home gateway and NFV infrastructure, guys. And what was the need of using this IoT? System management, automatic configuration was the first beauty, and coming to monitoring, optimization, operational and statistical data was the second duty. And you need to improve your reliability, and system-wide configurations are going to be updated. There will be multiple system configurations as well as retrieving the or reusing the configurations, etc. How to manage a device. This was the diagrammatic representation for managing a specific device in SNMP, which is a network station is going to be with you, and which is connected to network management station. And through that management station, you are connecting with SNMP, which is a simple network management protocol agent. From there, again, it will goes to the higher ups, and which is MIB, management information base. This is how the things are going to be managed. And what exactly the need of IoT systems are? SNMP is a well-known and widely used component, and this includes network management system, station, managed device, management information base, and this agent is going to run on a specific device, guys. And what are the different kinds of network operator uses? Easy of usages, distinction between configuration and state. And also we can fetch the configuration, and a network as a whole, it can be configurable, and configuring the transaction across the details and configuration details, dump and restore, configuring role-based control, consistency, multiple consistency, all these comes under STM. As I told you, it was a network paradigm which separates the network control and data planes. And coming to the network function virtualization, it is an approach which is involves with replacing dedicated network hardware, where n number of devices, hardware devices are working with software devices by creating the virtual network functions which runs on standard servers, storages and switches. In this particular network traditional, a special kind of hardware devices such as routers, firewalls and load balancers are used to perform specific network functions. And coming to the differences, both are the technologies which are aimed to improve the network agility, flexibility and efficiency. And this was the difference, how the scope was different. Here it is primarily focused, and there it was focused on virtualization. Coming to functionality, here there will be separate control plane. There we can using routing, switching, firewalling, etc. And deployment, SDN is typical. Why? Because it was a specialized network hardware. And NFV, which can be deployed on standard x86 servers also. Managed and SDN is typical to manage. And coming to architecture, this SDB is typically used to create a centralized SDN, whereas NFV on the other hand, which is focused on the virtualized network. This is about the differences of network abstraction. Have a look how the things are. The abstracts the network infrastructure from the control plane, whereas in NFV abstract network functions from the underlying hardware. Service delivery. This is how the service delivery in SDN and NFV. In NFV, service delivery models have been followed, and here it can be used to enable new service delivery models and vendor ecosystem. SDN has a larger scale of vendor ecosystem compared to NFV. Why? Because it is a new technology which is introduced in market, so that it is new. What are the need for IoT system management? Automatic configuration, monitoring operational and statistical data, improving reliability, system-wide configurations, multi-wide configurations, reusing and restating properties. What are the basic things of IoT management? Simple network management protocol. It is going to function like this. Pros and cons are going to be like this. And network con and ang. What network con first? A protocol which is defined to communicate the service of configuration management, which uses a secure SSH protocol. Ang, which is used for data model of network ang, which is a configuration data for devices. And these two are going to work together, where network con is providing the communication framework. Ang is going to define what and how the data is going to be accessed. For that, NetOP, what it was an open source platform, guys, and this suite is designed for network management and how it is going to start working, which is providing the tools for configuring management, monitoring, automation using of protocols. And coming to the next one, basics of IoT system, network configuration. This protocol is a session-based protocol. Once observed, there was a kind. The sessions, content, operations, RPCs, and transport. Ang is going to define contents and operators, and based on that operation, server is going to configure with the data storage, and finally Ang is going to define the things. And network configuration, as I told you, this was the layer which consists of both configuration and state, which is XML encoded, and it is going to give you a clear separation, whereas Ang is a data model which is used for configuration of network protocol, and Ang models defines the data which is exchanged between network client and server, which is a model which compromises the leaf nodes, etc. And what are the basics? The Ang is a Ang version of toaster embody. These having leaf nodes, and leaf nodes are going to define a type of description. Two different kinds of RPC definitions are existed here: make toast and cancel toast. These are the different things. And coming to the IoT system management, by using this network configuration and ANSA, managing the system, management the application programming interface, transaction manager, rollback manager, configuration validator, configuration database, configuration API, data provider API. These are the different kinds of things which are existed in network config, and the same thing was represented in form of a diagram. Once have a look, guys. That's it. We will meet with a small overview about the controlling hardware and sensors in the next class. Thank you, guys. This is about IoT network and management system, which is our complete overview about these things which we discussed so far. Software defined network, network function virtualization, and the differentiation between SDN and NFVs. All these things are covered so far. In the next class, I will start discussing with controlling hardware and sensors. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.